Okay. Now my voice is coming or not? Hello, hello, hello. Hello. Okay, one second. Abhishek, Abhishek Srivastava, and one more person is here, the Baua Biharka. Okay. So now the voice is audible or not? Mridul Raz, yes. Okay. So welcome to you all again on our English medium Exampur IAS YouTube channel. And just I said, but you all haven't listened just because of the lack of connection. We have completed atmosphere topic in which we have completed the composition of atmosphere, the definition, and also the some layers of structure of atmosphere in which we have completed the troposphere and the stratosphere portion. Okay, so today we are going to start with the mesosphere. Okay, we'll start with the mesosphere and then we will complete the ionosphere, thermosphere and the exosphere. And also today we will learn the heating and cooling effect of atmosphere and then the greenhouse effect also, because the greenhouse effect is also the very important topic for any exams. Okay. Now audible, that's good, Vivek, Mradul. Okay, so let's see first of all. So this is the class, the physical geography class we have started on this channel, totally based on the GC Leong and some NCRT. Okay. Then in the next segment we can see we have finished the definition part, composition of gases, and now we are covering the structure of atmosphere. I have given the ideas about the significance of atmosphere in the last class also. Okay, so come for the today's class topic, that's the we will start from the mesosphere. Okay, mesosphere. But before to go for the mesosphere, there is one more point I want to discuss with you all. That's the Kármán line. Have you ever listened this word? The Kármán line. Any one of you have listened anywhere? Kármán line. This is the line. Beyond it, there is a space. Okay. So now you see, from the Earth's surface, the Kármán line is for the 100 kilometer, and above it, the regions are referred as a space. So this one is the boundary of a space, and this is the zone above the mesosphere. So here it is a point, the Kármán line located within the thermosphere at an altitude of 100 kilometer and is commonly used to define the boundary between Earth's atmosphere and outer space. So what I said, you can see the thermosphere, stratosphere and mesosphere, and above it there is a line that is so called the Kármán line. It comes into thermosphere, ionosphere. Okay, or so come for the first topic of today, that's the mesosphere. Mesosphere. In the last class, we have finished the stratopause. Okay. Stratopause topic was finished in the last class. Today we are starting with the mesosphere. So first point about the mesosphere, temperature decreases with increases altitude. Temperature decreases with increasing altitude. Okay. Temperature decreases with increases altitude. First of all. And then you see, we have drawn one figure of this structure of atmosphere also. Like see, here we have mentioned the temperature and this side is the altitude. Okay. In thermosphere, we have seen that temperature decreases with increasing altitude and then there is a constant zone. then again the temperature increases, then the constant zone, and this time you can see the temperature decreases. So here you can see the mesosphere temperature decreases with increasing altitude. But just because of the thickness of mesosphere is relatively higher than the stratosphere, so the minimum temperature of atmosphere is found in mesosphere. So you have to write down one more point here. That's the minimum temperature of atmosphere. Minimum temperature of atmosphere is found in mesosphere. And what do you think? What about the temperature? Then it would be minus 90 degrees Celsius at the uppermost layer of mesosphere. Okay, so you can write down the second point about the mesosphere. First was the temperature decreases with increasing altitude. It was also happen in a troposphere, but now you can see in mesosphere the minimum temperature of atmosphere is found, and that is the minus 90 degrees Celsius. One more phenomena occurs in mesosphere, and that is the most important thing about the formation of noctilucent cloud and how such clouds forms in mesosphere. We are just going to see. पायल कहल जी का बहुत बहुत स्वागत है बच्चे. Hi. So next is an exceptionally noctilucent cloud can formed in mesosphere. Okay. So next point is an exceptionally noctilucent cloud formed in mesosphere. Okay, formed in mesosphere. But how these clouds formed in mesosphere? What about the concept behind it? Let's see. So first of all, we have to know how such clouds can form. Clouds form is just because of condensation process. Occurs above the dust particles, which works as the hygroscopic nuclei, which we have already discussed in our last class, Friday. Okay. So, how the dust particles reached in mesosphere, which over the condensation will process, condensation process will occur. So let's see. So there is a rock fragments of asteroids. You can see there is rock fragments of asteroids now coming towards the Earth's surface. And when it travels through the thermosphere and the exosphere, it's just because of the high temperature, the air molecules separated away. Okay, but whenever it goes downwards in mesosphere, it is 90, it is 80 kilometer, 50, 55 kilometer. When it enters into mesosphere, and you see, we have already discussed earlier, the density is high in the lower layer of atmosphere and density is rarer in upper layer of atmosphere. So when these rock fragments reach in mesosphere, it will collide with the air molecules. Okay, and then the frictions will occur, and then frictions will occur, and then it burnt up. So the rock fragments of asteroids getting burnt in mesosphere zone. So this one is the mesosphere. If it totally vanished in mesosphere, it is called the meteors. Okay, the rock fragments of asteroid, if it totally vanished in mesosphere, it will called a what? A meteors. And sometimes perhaps some rock fragments without totally burnt up, it reached to the Earth's surface. Then it would be called a what? A meteorites. Then it would be called what? A meteorites. Okay. So in Mesosphere research, we see some rock fragments of asteroid totally burnt up and releases what? And releases the dust particles, because that is made up of the rockies. So it releases dust particles or solid particles. And we know the dust particles or solid particles presence in air works as a hygroscopic nuclei, which over the condensation process will occur. So the temperature is below the -1, -2, -3, -4, -10, below the 0 degrees Celsius basically. And at 0 degrees Celsius temperature, air becomes saturated, and beyond it, you can see the condensation process will occur. And so the condensation process will occur over the dust particles in mesosphere, and thus forms a what? A noctilucent cloud. So here you can see a noctilucent clouds can form in mesosphere by condensation process occurs over the dust particles released through the meteors. Getting a point? So the questions demands how the noctilucent clouds can form, in which layer it is forms. Okay, so both concepts should be clear. Getting a point or not? Payal, Mradul, Vivek, Abhishek. Is it clear or not? How the noctilucent cloud can form in mesosphere. And why only such clouds formed in mesosphere? So first of all, the temperature decreases with increasing altitude, and the temperature it is in a minus. Also, the releases of dust particles from the meteors, that is the rock fragments of asteroids. Okay, so that is all about the mesosphere. Then we are coming for the Mesopause. So here it is 80 kilometer, and this side is 90 kilometer, and this one is called the Mesopause. This one is called the Mesopause. So what about the some points of Mesopause? So first of all, you should write down. It is a transition zone. Transition zone between mesosphere and thermosphere. Mesosphere and thermosphere. Then what about the thickness? So thickness is 10 kilometer, and the temperature are constant. So there is a constant temperature. So this is all about the Mesopause. Okay, Vivek Kumar, very nice brother. The concept should be clear. First of all, Vivek, Payal, Mradul. In UPSC, the most important thing is the concept clarity. Whatever you are learning, whatever you are studying, your concept should be clear. Because the whole questions of the even the prelims as well as the mains totally depends on the concept. How you represent your concept in a writing way. So Mesopause is over. Here we are coming for thermosphere. Now the next layer is thermosphere. It is also considered as the ionosphere. But whenever you will do a study of Stoller and the Savinder Singh, you can see the lowermost region or a lower region of thermosphere is called the ionosphere. Okay. So you can write down here also ionosphere. But how the ionosphere forms, that's the concept. How the ionosphere will form. So let's see. First of all, about the thermosphere. Here you can see the temperature increases with increasing altitude. Temperature increases with increasing altitude. And it will constantly moves. Okay, so temperature increases with increasing altitude. You can see this one is the air molecules. Right now, if we increase the temperature, it will be separated. Firstly, it will heat it, and then the heating objects moving fastly and expands, and so these air molecules, first of all, you can see separated away and becomes electrically charged particles. So this will become electrically charged particles because of increasing temperature, and thus it will considered as an ion. So the air molecules found in a electrically charged particles as the ions in thermosphere, and so this layer is referred as a ionosphere. Getting a point? So this layer is referred as a ionosphere. It's just because of the electrically charged particles are found in this zone. And how it happens? Because of the increasing temperature. Very warm welcome to Ashok Yadav. Good morning to you all again. So now we are discussing about the thermosphere or ionosphere. So ionosphere is a lower layer of thermosphere, nothing else. It is not the separate layer. Ionosphere, thermosphere is the same. Okay. And why the ions forms in ionosphere? Because of the increasing temperature. Okay. Then now you see some phenomena about the ionosphere. Firstly, we have seen several places the radio waves reflected back to space from ionosphere. So that's the next point you have to write down. Radio waves reflected back to Earth's surface by this layer. So radio waves are reflected from ionosphere. The next point is this. Radio waves are reflected from ionosphere. Rakshita, Bimlesh, very, very warm welcome. My classes will run on Monday, Tuesday, and Wednesday. Sorry for yesterday, I was not available. So I will try my best from the next week, and even I will compensate it with one more classes in this week. So radio waves reflected back to Earth surface from this layer. Now you see, this one is here it is 80, this one is 90, and you can see the 640 kilometer. And here above it, the 1000 kilometer. This one is exosphere, and here it is the thermosphere. And the lower layer of thermosphere, what we say? Ionosphere. This is called also the ionosphere. Now we come for the two phenomena of this layer. First of all, we can see the several layers has formed in this zone, and that is so called the D, E, F, and G. These are the layer formed by the different gaseous region, that is the nitrogen, the oxygen, and the hydrogen and the helium. Okay, so let's see. Here it is D layer. This one is E layer. Here it is F layer, and above it the G layer. So there are 4 layers forms in ionosphere because of the heating of air molecules. Now you see, this one is the Earth's surface, and the radio wave is moving to space. So it will moving back after collision with D layer. D layers reflects back to long waves. E layer reflects waves to medium waves. F layer reflects back to short waves. And the G layer reflects back to all waves. Okay, so D layer reflects long waves, E layer reflects medium waves, and the F layer reflects short waves. You have listened in a Vivid Bharati program or in a frequency modulation channel, FM channel, that ऐसा होता है कि ये प्रसारण विविध भारती कितने मेगाहर्ट्ज से शॉर्ट वेव से हो रहा है, समथिंग ऐसा आप सुनते होंगे. So that is the F layer by which the short waves return. In earlier stage, you have faced such interruptions of broadcasting in your TV in the eras of 90. Okay. So there a problem occurs of interruptions frequently in the day's time, but it won't happens at the time of night. Okay, so D layer reflects back to long waves, E layer medium waves, F layer short waves, and one more point I want to mention here. E layer is called what? It is called cannulae heaviside layer, and the F layer is called Appleton layer. So F layer is called Appleton layer, and the E layer is called cannulae heaviside layer. You have to also remember by which layer, which waves is returning back to the Earth's surface. Okay, returning back to the Earth's surface. जनरली जैसे कि आपने देखा होगा 90s के दशक के तो आप लोग होंगे नहीं, छोटे बच्चे हैं, उस टाइम में ना टीवी में रुकावट आ जाती थी, चलते चलते शक्तिमान चल रहा है बंद हो जाता था. तो होता क्या है ना कि जितने भी जो टीवी वाले जो सिग्नल्स होते हैं, दे हैव टू फॉलो द शॉर्ट वेव्स. तो दिन के समय में these 3 layers has well developed, but at the night time these two becomes weak. These two becomes weak in the time of night, and so the direct short waves reach to the F layer and reflect back to the Earth's surface. And that's why interruption doesn't, you can face such kind of things in at the time of night. Okay. One more phenomena we are going to take, that is the aurora. What is aurora? We are going to discuss. Here it is aurora. So first of all, what is it, how it forms, and what kind of questions arise from aurora? So let's mention it, aurora. It happens in ionosphere first of all. It happens in ionosphere. So let's see how it happens. So firstly, we can see aurora forms in a polar region zone, in a North Pole or a South Pole, firstly. And it happens in ionosphere. So we can see in ionosphere there is a electrically charged particles or ions are present. So you can see the electrically charged particles, ions are present in ionosphere, and the electromagnetic waves comes from the sun. Electromagnetic waves comes from sun. When these two collides with each other, it will produces a bright light that is so called the aurora. Getting a point? Firstly, listen very carefully. What is aurora? Where it forms? So it forms in ionosphere. How it forms? So when the electromagnetic waves comes from sun, collides with ions present in ionosphere or electrically charged particles present in ionosphere, then after collision, it produces a bright light of different colors, is called aurora. This phenomena is called aurora. You can see it in a polar region only. You can see it in a North Pole or a South Pole region. In North Pole region, it is so called the aurora borealis. In North Pole region, it is so called the aurora borealis, and in South Pole, it is called aurora australis. Okay, australis means south, and so the name given to the Australia, australis. Rakshita Subhasini, very, very warm welcome. So, have you got this concept or not? Ki how the aurora forms in ionosphere? What about the factors behind it? The firstly, you should remember the things. The electromagnetic waves comes from the sun. When it collides with the electrically charged particles of ionosphere present in ions present in ionosphere, when these two collides, it produces a bright light, and that is so called the aurora. Okay, and these phenomena are called aurora borealis at North Pole and aurora australis at South Pole. Vivek, Rakshita, Rimzim, Subhasini, Mradul, very nice. Okay, above it there is a layer of exosphere. You can see we have mentioned the three pause region, the tropopause, the stratopause, and the mesopause. But we haven't mentioned the thermopause. It just because the temperature increases in both regions, in thermosphere as well as the exosphere. So how can be a pause region there? Pause region will occurs when the temperature in the one layer temperature decreases and in another layer temperature increases, and then there should be some a transition zone. But in these two regions, temperature rapidly increasing, so the pause is neglect there. So come for the exosphere. Exosphere having a thickness beyond the 640 kilometer to 1000 kilometer. Okay, 640 kilometer to 1000 kilometer. Temperature increases with increasing altitude. Temperature increases with increasing altitude. Temperature increases with increasing altitude. And you can see above it there is a magnetosphere. Above it there is a magnetosphere, and there is a layer, a belt, which protects us from the cosmic rays comes from the another celestial bodies, and that is so called what? A Van Allen radiation belt. Van Allen radiation belt. So this is the zone by which this is the zone which protect our atmosphere or our Earth from the cosmic rays or a hazardous cosmic rays comes from another celestial bodies. Okay. Is it clear or not? So one more time, we have just discussed the Carmel line, which is found in a thermosphere region, and now I am going to discuss the homogeneous and heterogeneous layer. Okay, homogeneous and heterogeneous. But before to go for that, there is a point, that's the atmospheric escape. The most important point about the recent phenomena, atmospheric escape. What do you think about it? Atmospheric escape. The gases having a tendency to move out. Let's see. Certain light gases like a hydrogen and are constantly lost into a space from exosphere due to atmospheric escape. These light gases having a tendency to move out or escape out. Okay, the atmospheric escape of gases happens when gas molecules achieve escape velocity due to low gravity or due to energy received from the sun, heat or solar winds. So what do you think ki at the time of the solar winds, this phenomena will occur more? Okay. Mradul Raj, magnetosphere is above the exosphere. Okay, it doesn't comes into exosphere. What I have said, the magnetosphere is above the exosphere. So exosphere remains in a 640 km to 1000 km, and beyond it there is a magnetosphere. ठीक है, ये ध्यान में रखिएगा. Beyond it कर सकते हैं यहाँ पर. There is a magnetosphere, and in this layer you can see the Van Allen radiation belt, and this belt is responsible to protect our Earth from the hazardous cosmic rays comes from the another celestial bodies of our solar system or our galaxy. Yeah, Subhasni, that's the 100 km. That's good. Very nice. So this one is atmospheric escape concept. And one more point, you see, Jovian planets retain gases with low molecular masses because of low temperatures and higher gravity. You see, the Jovian gases comes the Jupiter, Saturn, Uranus, Neptune. These four are considered as the Jovian gases. These are light gases, light planets. Okay, these are totally made up of gases, not the rocky materials, as like the Earth, Mars. Okay. So Jovian planets retain gases with low molecular masses because of low temperatures and the higher gravity. You see, this one is Sun. When you are going away from Sun, the temperature decreases. Temperature decreases. And so the Mercury, Venus, Earth, Mars, then the Jupiter, Saturn, Uranus or Neptune. So these four are the Jovian gases made up of light gases. But these gases cannot escape out just because of low temperature and higher gravity. Why the atmospheric escape out phenomena occurs in Earth atmosphere? It's just because it is nearby to the Earth, and whenever at the time of solar winds, it produces maximum heat, and just because of those heat phenomena, these gases of hydrogen and the heliums will move outwards. Okay. Then next point, Titan, a moon of Saturn, and Triton, a moon of Neptune, possess significant nitrogen-rich atmosphere. One more point you have to add in your notebook. Earth's magnetic field reduces atmospheric escape. Very important point. You should remember. Earth's magnetic field reduces atmospheric escape by protecting the atmosphere from solar winds that would otherwise greatly enhance the escape of hydrogen. If Van Allen radiation belt have not present above the exosphere or in a magnetosphere, the tendency of escape out of the hydrogen gas maximum occurs in the upper region of the atmosphere. And there will be lack of hydrogen at that time. Okay. So, we are going for one more concept. Let's see. There is a 3 layer in the lower region. This one is thermosphere. Here it is a stratosphere. And this one is mesosphere. These 3 layers are referred as a homogeneous layer. Homogeneous layer. But above it, there is a 2 layer, the thermo and the exo. These 2 are heterogeneous layer. So gases remain in uniform condition in this region. While in heterogeneous layer, gases found in non-uniform condition. So you see, in a homogeneous layer, the percentage of gases remain constant. But in heterogeneous layer, it varies. Okay, it varies. Jitendra Kumar, we will launch our bilingual batch for Geography Special very soon. Okay. The most important thing is the concept. You should focus on that area. If you got the concept, you will clear the or solve the all questions. So, the homogeneous layer and the heterogeneous. What kind of questions can be raised? Homogeneous layer consists of which layers? Then you can see the mesosphere, stratosphere and thermosphere. Oh, sorry, troposphere. यहाँ पे troposphere करेंगे. It consists of troposphere, stratosphere, mesosphere. Here is the thermosphere, not this part. And these heterogeneous layer consists of exosphere and thermosphere. ठीक. Okay. Now, importance of Earth's atmosphere. What about the significance of our Earth's atmosphere? It provides a life-giving gases. It regulates the entry of solar radiation. Okay. Temperature balance, blocks harmful radiations. That is a well-known radiation belt. Blocks the harmful radiations. Shields the Earth from impact objects like meteors or meteorites. Okay, and here you can see the Van Allen radiation belt. Then weather and climate associated with these layers. Water on Earth exists in liquid state due to atmosphere and the scattering of light. So these are the some significance or the importance of Earth's atmosphere. Then we are coming for next phenomena. Okay, come. You can get our PDF from example official application. Okay. Now we are coming for the insolation. What do you think about it? What is it? Insolation. Anyone can define or not? What is insolation? What do you know about the insolation? Like, see, this one is Earth's surface. In a space, there is only one phenomena occurs by which the heat transfers, and that is so-called the radiation. So you see, here it is sun, and heat receives by Earth's surface from sun in the form of short waves by solar radiation process. So you see, heat comes to Earth's surface in short waves through solar radiation. So the definition becomes incoming solar radiation in the form of short waves are called insolation. That is the insolation. Now the very nice questions asked by the Subhasini. PSLV and the GSLV. I will explain definitely. Give me a little bit time. Like you see, here it is Earth, and the PSLV established in exosphere. PSLV established in exosphere, while the GSLV fixed in this part. GSLV fixed at 36,000 kilometers above the Earth's surface. Above Earth's surface. GSLV satellites are a weather-related satellite. GSLV satellites are the weather-related, while PSLV satellites are the information and broadcasting, communications, information, broadcasting, communication. So communication satellites, broadcasting satellites settle down in a exosphere zone. You should remember. Very nice, Subhasini. You have asked this question. GSLV satellites are weather related and it fixed at 36,000 kilometers above Earth's surface, and it is so called the geosynchronous orbit. Geosynchronous orbit. Also the geostationary orbit. Okay. also the geostationary orbit. Vivek has given the right, Suhasini has given the right explanation. Okay. So, if we talk about the sun, the sun is the source of energy to Earth's surface or to Earth, simply. Getting a point or not? So, that is the ultimate source of heat, and the differential heat received from sun by different regions on Earth is the basically the ultimate reason behind the weather phenomena occurs over the Earth's surface or the climatic conditions. Huh? So what about the insolation? One more time I want to explain. The proportion of solar energy received or intercepted by Earth. It is proportion of solar energy received or intercepted by Earth. Getting a point? So you can write down this sentence also. The proportion of solar energy received or intercepted by Earth. What amount of energy received to Earth from the sun, that is so referred as a solar constant. So by which rate, next one is the rate by which the solar energy comes to the Earth's surface. Solar energy comes to the Earth's surface, and that is the solar constant. So solar constant is the rate by which the heat received to Earth from the sun. So this one is the rate. And it is 2 calorie per square centimeter per minute. This one is the solar constant. Energy or radiation? Energy comes through the radiation. That's why we use such points here. Okay. So energy comes through the ultraviolet radiation. One more thing we are going to explain here. Why it is mentioned the solar constant? Because it always remain constant. Okay. Let's see one more point. Now you see from the Earth, the energy received to from the sun, energy received to the Earth in the form of solar radiation. Or it is in the form of short waves. When the Earth got heated, now the surface becomes the heated. It also emits the heat into a space. This one is a space, and now we have learned it. A space is beyond the 100 kilometer, that is the Kármán line. So when the Earth has got heated, it will also emit the heat in the form of what? In the form of terrestrial radiation. In the form of terrestrial radiation. And that is the long waves. Here you have to know that's the any object by the Stephen Boltzmann coefficient, any objects having the temperature more than minus 273 degrees Celsius will emit the heat. Now the surface is heated, so it will also emit the heat. by the Stephen-Boltzmann coefficient. But now the concept behind it, कि maximum the heat, shorter the wavelength, and lighter the heat, longer the wavelength. By the second law of thermodynamics. Energy, we should use the radiation by which the energy comes to the Earth's surface. You have to use radiation. And what is it? It is the energy. This one is the solar energy. So solar energy received to the Earth through solar radiation in the form of short waves. Okay. Is it clear? जय हो बच्चे ने नाम रखा है. बंद करके क्यों चला जाता है? Now it is clear or not? Yeah. Mradul, Jai Ho, Subhasini, Vivek. Basically what? The Earth receives radiation. Radiation what? That is the heat. Jai Ho. Radiation is what? That is the heat. It is the heat. Or nothing else. This is the heat. So Earth receives sun's radiation. That is the heat in the form of short waves. Which are of what? The electromagnetic in nature. Electromagnetic in nature. And the Earth absorbs short waves radiations during daytime and reflects back into the heat received into a space as long wave during night time. You can write down this sentence also. Earth receives sun's radiation in the form of short waves. Yeah, exactly. जो भी बच्चे जय हो के नाम से होंगे. Earth receives sun's radiation, that is the heat, in the form of short waves, which are of electromagnetic in nature. And then the Earth absorbs short waves radiations during daytime, and it reflects back to the heat received into a space as long waves radiations during night time. Okay, so here it is the UV rays, and this one is because of the longer the wavelengths. This one is the infrared waves. Infrared waves. Is it clear now? Now we are going for the ways of transfer of heat energy. Now we are going for ways of transfer of heat energy. How the heat energy transform from one layer to another layer, one place to another place, one region to another region. So now we are going for that. Here you can see the such phenomena which is responsible for the heating and cooling effect of atmosphere or the earth also. Heating and cooling of earth atmosphere. And such phenomena are what? The first one is radiation. Second one is conduction. third one is convection, and the fourth one is advection. Here we will learn the advection process also. So what do you think about the radiation first of all? What is radiation? Can anyone explain? What is radiation? Let's see. In radiation, basically heat transfer from one layer or one body to another body without actual contact or a movement. And it is possible in relatively emptier space, like from the sun to the earth. So first of all, coming for the radiation, in Hindi it is so called the Vikran. Sometimes questions Vikran. You should must remember point, that's it. But the radiation is most. So write down one more point here. In radiation, heat transfer from one body to another body without contact or movements. Heat transfer from one body to another without contact or movements. Okay. Yeah, exactly. Very nice. Very nice explained by Jaiho. What your real name, I don't know, but we have explained very nice. We are coming for that concept also, and we will discuss it with the gaseous greenhouse gases. Okay. So radiation, that is the heat transfer from one body to another without actual contact or movements. Then it is possible in emptier space only. Such kind of phenomena occurs in emptier space only, because there is a lack of gases, solid or a liquid. Okay. Now come for the conduction. Now we are coming for the conduction. Once the Earth's surface heated, now you see, by the radiation process or a solar radiation, Earth's surface becomes heated and the surrounding region of air molecules will also get heated by the heat transfer from one layer to another layer by the conduction process. So this is the process by which the lower layer of atmosphere get heated. That is the conduction. So heat transfer through matter by molecular activity happens in conduction. Like you can see in iron, the heat transfer from one layer to another layer and one side from to another side. If you heated the one side of the iron, the whole iron will heat it. Is it happened or not? So heat transfer through matter by molecular activity. This is not right sentence. Vertical increase in temperature of atmosphere is not right. Okay. One more point I want to discuss here. Heat transfer in iron and other metals through the conduction. You have to one more point you have to add. Firstly, write down one more point. By the conduction process, heat transfer from one layer to another layer. by the conduction process, heat transfer from one layer to another layer. First point. Second, like example, like in iron or other metals, heat transfer through conduction process. In also generally the denser materials like water or a good conductors, and the lighter medium like air is a bad conductor of heat. So denser materials, one more point you have to write down here. Denser materials are good conductor. While the lighter medium, denser materials क्या हो गया? Iron, metals. Like the lighter materials, like air, is bad conductor. Lighter materials like air is the bad conductor. So this one is the second conduction process. Next we are coming for the third one, that is the convection. It is convection. So here we have just seen the surface is heated. Surface is heated by the heat received through the sun. Now the air becomes warm because of the conduction process. Now the air becomes warm. Warm air you have to mention here. Warm air becomes the lighter, and then it will move upwards, and the vertically heat transfer by the convection process. Vertically heat transfer by the convection process. It occurs in atmosphere as well as the ocean. Atmosphere and oceans. In both regions you can see the convection process. Okay. Clear or not? Yeah, obviously. Air is insulator. So in convection process, we can see the transfer of heat energy by actual transfer of matter. Transfer of heat energy by actual transfer of matter. Clear point? So you can see the warm air of this place. The warm air of this place is rising above and reach to this place. So this is by the convection process. Like see in oceans. In oceans you can see the cold water moves upwards. That is so called the upwelling. The process is remains same, the convection. This one is called the convective waves. Okay. Sometimes you can see the downwelling. So in convection process, this convective currents sometimes arise and sometimes gone down. Conduction and convection, okay, no issue. So this one is the convection by which the whole atmosphere get heated. Atmosphere heated by convection process. Atmosphere heated by convection process. Lower layer of atmosphere heated by conduction process. But the whole atmosphere you can refer the convection process. Okay. And the one more, that is the advection. Heat transfer horizontally from one place to another place. Like you see, this is the surface. Here it is the warm air. Here it is the cold air. And both moving by the winds. And this one is the warm winds. And here it is the cold winds. Because when the speed and the direction achieved to the air substance, it becomes the winds. So winds is what? It is nothing. Air in motion and having direction. That is so called the winds. Nothing else. Air in motion and having direction is so called the winds. So firstly, here it is the warm air, it is the cold air. Now it's having their own directions and the movements is happening. And so this one is called the warm winds, and warm winds will raise the temperature of this site. Will raise temperature. And here the cold winds will down the temperature. Like you can see in recent scenario, heat waves is going on in the northern region of India. Anyone, like why think about the iron? It will happen with the some other materials also, even in lakdi, wood, any objects. So this is the advection process in which the heat transfer horizontally from one place to another place. Yeah, basically, definitely Vivek Kumar. Advection process is responsible for fog also. Like you see, like I have just mentioned, it happens in atmosphere, also oceans. So like you see in oceans or Earth's surface, here comes from the cold, here comes from the warm. And when these two meets, it will create what? It will create another weather phenomenon that is so called the fog. It will create fog. So fog happens through the advection process also. Is it clear? Now we are coming for factors affecting temperature variations. Okay, but before to go for that, we should learn the greenhouse gas concept. Okay, greenhouse gas concept. Let's see. It measures in CO2 gas Let's see what happens. This one is the Earth's surface. And the solar energy comes through the solar radiation in the form of short waves. And when the earth got heated, it will also release the terrestrial energy in the form of terrestrial radiation in long waves. And this one is atmosphere. And there is a greenhouse gas. Greenhouse gases are responsible to maintain the temperature variations over the earth. If it will not present over the earth, life can't sustain, because it absorbs the heat, reflects back to a space by earth in the form of long waves. So greenhouse gases, mostly the CO2 gas, absorbs long waves only. It won't absorb the short waves. It absorbs only the long waves. And so the maximum heat received to the Earth's surface at the time of 12 to 2 p.m. 12 to 2 p.m. But the maximum heat felt by the living things at the time of 2 to 4 p.m. 2 to 4 p.m. Yeah, 2 to 4 p.m. Why? Because at this time, when Earth reflects back to energy into a space, that will be trapped by the greenhouse gases present in this zone. Now you see, greenhouse gases trap this heat into atmosphere. And because the greenhouse gases only absorbs the long waves, so the temperature increases at the time of 2 to 4 p.m. So firstly, the surface should be heated, and then the air will become warm. Okay. And when the Earth's surface releases the temperature into a space, that will be trapped by the CO2 gases. In recent scenario, the global warming, the climate change happens over the Earth's surface across the world because of the increasing emission of gases such like a methane or a CO2 gases and some others gases. Like see, greenhouse effect. The CO2 and other gases in the atmosphere trap heat, keeping Earth warm. So this one is in a normal condition. This one is in a normal condition. Without CO2 gases, even a biotic things can't sustain over the Earth's surface. Here we can see the short wavelength coming to the Earth's surface and the long wavelengths releases to the space, and that was the trapped by the Earth's atmosphere. Earth atmosphere trapped the outgoing terrestrial radiation. This one is the incoming. This one is the incoming solar radiation, and here it is the outgoing terrestrial radiation. This was trapped by the CO2 gases. Okay. In next slide we see how we know we are causing global warming. How? So these are some facts we are giving to you. Like you can see the shrinking upper atmosphere. Upper atmosphere is shrinking. How can we know the causing global warming? That's the point mainly. Cooling upper atmosphere, less heat escaping to a space. Okay, less heat escaping to a space. A rising tropopause. Tropopause layer will move upwards. More fossil fuels, carbon in the air. more heat returning to the earth. When the CO2 gases and some other greenhouse gases will increase in atmosphere, it will trap maximum amount of heat reflected back to space by the earth. Then pattern of ocean warming. Winter warming faster than summer, nights warming faster than days, less oxygen in the air. Definitely less oxygen in the air. Then now one more fossil fuels carbon in trees, more fossil fuel carbon in coral, and the more fossil fuel carbon in ocean. So these are causing the global warming. Okay. Next, impact of global warming is what? The questions arise from this slide also. Impact of global warming. What is the impact of global warming? When the heat increases in our lower atmosphere, it will melt down the snow. It will maximum vaporize the water of lakes, the rivers. Groundwater level will go down. Transpiration will occur maximum in trees, in forest region. So like we can see, the changing rain and snow pattern, the impact of global warming is that the changing rain and snow pattern, stronger storms, higher temperature, more heat waves, like we are feeling in recent scenario or not. Maximum temperature, the more heat waves, it indicates the global warming. Changes in animal migration and life cycles, it also happens in recent scenario. More droughts and wildfires, Dawanal. Thawing for permafrost region will shrink. Changes in plant life cycles, warmer the oceans, the coral will bleach. So the warmer the ocean, rising sea level, it will damage the corals. So coral bleaching will happen if the surface temperature of ocean will increase by the 1 degree Celsius. Getting a point? Coral bleaching will happen if the temperature will increase just by the 1 degree Celsius ocean. So these are the impact of global warming. We can see here. And some others are also. Okay. Now we are coming for one question is for you. The atmosphere is mainly heated by the what? Choose the right one. Yeah, coral damage. Can you give the right answer to this question? Coral damage will happen definitely, Mradul, and I will explain it. Subhasni. Firstly, give the answer of this question. And then we will go for the factors affecting the temperature distribution. Atmosphere is mainly heated by the what? We have just discussed the atmosphere is mainly heated by the heat trapped by the CO2 gases, and that is the long waves. Long waves, terrestrial radiation. You can write down also here outgoing. This one is incoming. Oh no. Long waves. Subhasini, why the short waves? I have just explained by the short waves radiations. Our surface is heated only. Air is not getting heat through the solar radiation. So the answer is B. One more. Like see this point. The main reason that the Earth experiences highest temperatures in the subtropics in the northern hemisphere rather than at the equator is what? We have discussed it in the first class. So what will be the answer? I have just explained the greenhouse gases will only absorb the long waves, not the short waves. And long waves releases by the Earth's surface. No, Nishant Dahiya, I haven't seen. But I have planned to move the Maldives and the Lakshadweep. There I can see. You can also see corals in Andaman and Nicobar, Nishant. So if you like this class, you can like and share our classes also. Long wave is the main cause of heating only. Barrier need to what I said, just see. I just explained the greenhouse gases only absorbs the long waves which releases by the Earth's surface. It won't absorbs the short waves comes through the solar radiation. One more point I will add here about the water vapor. But before we will discuss this question, let's see. Mradul has given the 2C. Let's see. Subtropical areas have an enhanced greenhouse effect compared to equatorial areas. Subtropical areas tend to have less cloud cover than equatorial areas. Subtropical areas have longer day hours in the summer than the equatorial. Subtropical areas are nearer to the oceanic areas than the equatorial locations. बताओ क्या हो जाएगा इसमें से? अब जैसे you see here the Mradul has given the answer. The subtropical areas have an enhanced greenhouse effects equatorial areas. This is wrong, Mradul. CO2 gas remain constant at everywhere. And also you can see it releases by the maximum the developed countries. Here you can see the subtropical areas tend to have less cloud cover than equatorial areas. Subtropical areas के ऊपर में अगर देखें तो क्लाउड्स कवर जो होते हैं वो कम होते हैं। इक्वेटोरियल रीजन पे हर दिन क्लाउड्स फॉर्म करते हैं और हर दिन वहां पर रेनफॉल होता है। ओके, अब देखिए सब ट्रॉपिकल एरियाज हैव लॉन्गर डे आवर्स इन द समर देन द इक्वेटोरियल। सब ट्रॉपिकल एरियाज की जो समर की हम लोग बात करते हैं, समर का दिन इक्वेटोरियल रीजन से अधिक होता है। ये भी कुछ हद तक सही है। सब ट्रॉपिकल एरियाज आर नियर टू द ओशनिक एरियाज देन द इक्वेटोरियल लोकेशंस। देखने के लिए तो सब लगेगा कि ऑल इज राइट, but most suitable is what? The main reason that the earth experiences highest temperatures in the subtropics in the northern hemisphere rather than at the equators. And the most probable answer is the A. Most probable answer is the A. सबट्रॉपिकल एरियाज में क्लाउड क्या हो जाते हैं? कम हो जाते हैं, टेम्परेचर हाई होता है। इस रीजन में टेम्परेचर क्या होता है? हाई ही रहता है, क्लाउड्स कम होंगे। अब देखिए, क्लाउड्स अगर ज्यादा होंगे सो इट विल रिफ्लेक्ट द हीट, क्लाउड्स अगर अधिक होंगे इट विल रिफ्लेक्ट द हीट, और इफ क्लाउड्स इज नॉट प्रेजेंट the heat will comes down to the surface. Heat will comes down to the surface. So the maximum heat will received by the earth's surface. One more point अभी यहां पर मैं आपको बताना चाहूंगा, वन बाय वन। ठीक है, वन बाय वन देखते हैं। देखिए, now the heat will releases by the earth's surface, or if the less cloud will be there, it will releases into a space. It will releases into a space. So the balance is there. So the balance is there. Next, subtropical. If we talk about the subtropical areas have longer day hours in the summer than the equatorial. So equatorial having a moreover same situation consists for the full year. Or subtropical areas have longer day hours in the summer doesn't mention the it experiences the highest temperature in subtropics. Subtropical areas are near to the oceanic region. अगर हम लोग इसकी चर्चा भी करें तो this one is also not so much suitable. Not so much suitable. So the lastly, the answer given by, now we are going for the most probable answer. Remember always what I said. Two things happens. If the clouds covers the most, the reflection is maximum. So the less amount will come. Less amount will come. Second, if the sun rays comes to the earth's surface, clouds is less. So the maximum happening of what? Terrestrial radiation, long waves maximum happening. So the balance is here. So the balance is here. Okay. Then the most important point about the question, subtropical areas have an enhanced greenhouse effect compared to equatorial areas. It reflects what? It reflects the main reason. What? Like see. Key in subtropical areas, like you can see, there is a less amount of clouds. That's good. But there is a CO2 gases. Or because of the descending air, because of the descending air or a descent air, we talk lots of concept behind it. The subtropical regions are the maximum heat than the equatorial region. Okay, clear hai? So CO2 gases are there, but the most important thing is that the greenhouse effect. अब यहाँ मैं एक चीज और बताना चाहूंगा यार, यू आर वेरी राइटली सेड, जय हो, व्हाट्स योर गुड नेम, व्हाट आई सेड, प्रोपोर्शनली अगर देखा जाए तो इनमें से कौन बेस्ट हो सकता है, दैट इज द मोस्ट इंपॉर्टेंट थिंग। क्लाउड कम क्यों होंगे, जो मृदुल ने लिखा वो मैं आपको जनरली जैसे बताया कि उन भागों में क्या होते हैं, इक्वेटोरियल रीजन्स के आसपास के जो रीजन होंगे वो समुद्री भाग के होते हैं, तो वहां पर वाटर वेपर ज्यादा होता है, कंडेंसेशन प्रोसेस अधिक होते हैं और वहां पर बादल ज्यादा बनते हैं। जबकि सब ट्रॉपिकल रीजन की हम लोग चर्चा करते हैं, सो वहां पर यू कैन सी द टेम्परेचर इज हाई बट द क्लाउड्स इज लेस, क्लाउड्स वहां पर लेस हो जाएंगे। ओके, सो चारों रीजन्स में अगर हम लोग देखते हैं बेसिकली, तो यहां पर आपका जो हो जाएगा कि सब ट्रॉपिकल एरियाज टेंड टू हैव लेस क्लाउड्स कवर देन इक्वेटोरियल एरियाज। वो एक कंसेप्ट सही है जो मैंने आपको यहां पर बताया है कि दिस विल हैपन, बट द मोस्ट इंपॉर्टेंट थिंग इज द कि मैक्सिमम अमाउंट ऑफ हीट विल रीच टू द अर्थ सरफेस, maximum amount of heat will reach to the earth surface, clear point, maximum amount of heat will reach to the earth surface. So that's why we will choose this point, the subtropical areas tend to have less cloud cover than equatorial areas. Just one more point I have to add, because of less moisture or a less moisture. Why the less moisture? Because this reason the trade winds will move downwards also. So we will learn it later on. Okay, we will learn it later on. Arshita, okay, very nice, very good name. Also, I am trying my best to deliver the most of the content in English. We are generally what we deliver the whole content in a bilingual manner, but I have to work on this thing also. So I have taken it as a challenge and I will do manage very soon. Take Mradul, yeah, exactly. Because of the bilingual manner, na? But we will definitely do manage in later on. जब तक आप मेहनत करते हैं, कोशिश करते हैं, तो और बेहतर कर सकते हैं और बिल्कुल कर सकते हैं। एक ना in next very next class we will learn the factors affecting the temperature distribution. How the what about the factors which is responsible to manage the temperature over the Earth's surface, like a duration of the sunshine, okay, and the most some other phenomena are also there. आज गर्मी बहुत ही ज्यादा है। That's good. But if you have chosen the English medium, then you have to write in a proper way. Okay, first of all, then you have to appear in interview also in through the English. Okay, Mradul, Arshita. I got it. So is this clear or not? Arshita. So this concept has clear or not, so what we have discussed today. tomorrow we will discuss the factors affecting the temperature. Okay, factors affecting temperature. We have finished the Earth's atmosphere, composition and structure of atmosphere, significance. The carbon line we have cleared. Today we have discussed the homogeneous and the heterogeneous layer also. Then we have discussed the atmospheric space escape, homogeneous heterogeneous layer, and then the insolation, solar constant, and the ways of transfer of heat energy. So these are the topic today we have discussed. And the greenhouse effect. And the greenhouse effect. ओके, सो आज की क्लास को यहीं तक रखना चाहेंगे और कल फिर इसको आगे लेकर चलेंगे. कल की इन टुमारो लेक्चर वी विल डिस्कस द फैक्टर्स अफेक्टिंग टेम्परेचर एंड देन द एल्बिडो, inversion of temperature, and then we will go for the pressure belt and the winds. Okay, and later on we will take the chapter of cyclone, and I will give you some concept about the fronts also. Okay. Okay, so आज की क्लास को यहीं तक रखना चाहेंगे. हाँ, ग्रीन हाउस गैसेज में गैस के नेम भी पूछ ली जाते हैं, ये बिल्कुल आपकी बात सही है. इसको ग्रीन हाउस गैसेज में गैस के नेम भी लिखकर आप रख सकते हैं. ग्रीन हाउस गैसेज जिसमें कि आप देखेंगे कि जितने भी CO2 हो गए, मीथेन हो गए, क्लोरोफ्लोरोकार्बन हो गया, सब इसमें आ जाएगा. इवन हाँ, मैं एक चीज और मेंशन करने वाला था ना, देखो अबाउट द वाटर वेपर. वन कंसेप्ट about the water vapor. Water vapor absorbs short waves and long waves both. So you can see where the water vapor is maximum in those regions, there is the maximum heat will be found. Okay, so water vapor is responsible for the maximum heat in greenhouse gases. It also comes in a greenhouse gases. Maximum responsible is water vapor. If the water vapor increases in some region, there should be maximum heat. Okay. Okay. Then आप लोग अभी जो ग्रीन हाउस गैस लिख रहे थे, CO2 गैस, CH4, नाइट्रस ऑक्साइड, वाटर वेपर, ये सब के सब आपको ग्रीन हाउस गैसेस हो जाते हैं, ध्यान रखिएगा. इवन CFC, ओजोन, ये सब these are called the greenhouse gases. Okay. So that's all about the today's class. In tomorrow we will discuss the topic which I have just said. Okay. So thank you for your today's class. Meet you all tomorrow. Till खुश रहिए, स्वस्थ रहिए और एंजॉय करते रहिए लाइफ को, क्योंकि जिंदगी में एंजॉय करना सबसे ज्यादा जरूरी होता है. और कंसेप्ट पर फोकस करके रखेंगे. कंसेप्ट सही है तो आप सब कुछ कर सकते हैं, बिल्कुल कर सकते हैं. ओके, सो मिलते हैं कल आप लोगों से क्लास में. तब तक के लिए नमस्कार, धन्यवाद.